Welcome to Unconventionally Python. This presentation is about the move method that is used to relocate objects of the graphics.py library. The move method is widely used in programming games to continuously move objects around. The movement of the object appears to flow rather than jittery jumps. We accomplish this, the object flow, by emulating the techniques of a flipbook. By emulating techniques from flipbook, we mean that we move the object a little and then we suspend the program execution. Again, we move the object a little, we suspend the program execution, and we repeat this process time and again until the object reaches its final destination. There is a Python implementation for suspending program execution. Here is the statement. The parameter is a number representing the delay of the program execution in seconds. Let's give an example. In this example, the time.sleep parenthesis 0.2 statement, it tells the computer to suspend the execution of the program for 0.2 of a second. The .sleep method is not embedded into the Python core, but is rather an implementation of a Python library, and we should tell the Python where to find this library. Let's examine the Python code that was used to produce the motion of the object that we saw before. Here is the Python code when we started to implement the movement of a circle object from the left side of the canvas to the right. I will go very slowly and I'll try to explain almost one line at a time. The line number 1 tells the system that it's going to deal with the objects that have been implemented as part of the graphics.py library. Line number 2, it tells the computer that the program is going to use a method called .sleep, and that method is implemented in a library called time. So we have to bring, in a sense, into the Python awareness of these two libraries. Line number 4 tells us the name of our module. Lines 6 and 7 create the window with those specific characteristics. Line 10 through 12, as we have seen, creates object of type circle and calls it circle Q, places in a certain location, and that is the object we will move to the right along the x-axis horizontally. So line 15 moves the object, and then line 16 suspends the execution of the program so the human brain can record that, see that the object can be moved. Line 18 moves the object. Line 19 suspends the program. Line 21 moves the object. Line 22 suspends the program. And that's how we have moved the object. I assume that you can sense the possible issue, and that is, if we had to move an object many times, the program would have been extremely long if we had to repeat the same statements time and again. So what we have to do is identify the code that is repeated, and then we'll see how we can tell the system we want those statements to be repeated, executed time and again. So we obviously, I assume, we see here that lines 15 and line 16 are repeated again and again and again. So there is a way to tell Python to repeat things time and again, and here is the statement that we use to perform repetition. Line 14 is the structure, is how we tell the computer to repeat some code. For the time being, let's use this statement as is. We'll explain it at a later time. And simply, instead of 15, you can put any number, and that number within the range, it tells the computer how many times to execute the code that follows. Make sure though that you end the statement with with a colon, and make sure you indent once all the Python statements that you wish to be executed time and again and again. We will explain the meaning of the I, the meaning of the range at a later time. For the time being, if you want to move, for example, something, an object, you say for I in range, parentheses, inside the parentheses, you tell the computer how many times you want the code to be repeated. You close the parentheses, you put the semicolon, you go to the next line. The next line will be indented to indicate that whatever has been indented will be part of the loop, part of the repetition. So in this example, the line 17 and the lines 18 are executed 15 times. So it is as if we had these two lines 15 times in the code. Let's see the entire Python code from beginning to the end that was used to implement the circle motion from the left to the right. Here it is. Again, I'm not going to go through all the lines. I will just point out that lines 10, 11, and 12 create the object of a circle, place it on somewhat on the left of the canvas. And then the lines 18 and 19, they move the object, they suspend, they move the object, they suspend, and the numbers of the repetitions, or how many times lines 18 and 19 will be executed, is indicated by the number 20, which is within the range. Again, use the for I in range as given, put in the parentheses how many times you want this followed code to be repeated, and that's how we implement repetition. So let's compare how we started and how we ended with moving the ball from one place to another. On the left, we have how we started, writing the movement and the suspension explicitly. To the right, we see that we have a much more compact code, and actually on the left we have 6 repetitions, 6 movements. On the right we have 20. We have refined the numbers of lines 18 and 19 comparison to their equivalent on the left side, just to smooth the movement a little bit, but in terms of logic, the idea is the same. Obviously, you see that there's an advantage in using the for structure for repetition instead of writing the same code time and again and again and again. That is, for the time being, about moving an object and using a loop, that's what we call the repetition sometimes, to repeat some statements time and again. And although in this example we repeat 2 statements, you can have any number of statements that you wish to be repeated. Thank you for watching, and as usually, please practice, and hopefully I will see you soon. Thank you.